Hello student, I am Sanap KB, Department of Physics of RBNB College, Shirampur. This is my fifth lecture on this topic, current electricity. In previous lecture, we completed all the theory part of this topic, current electricity. Today we are going to solve some numericals concerned with this topic. Now see here the first numerical, a battery of EMF 4 volts and internal resistance 1 ohm is connected in parallel with another battery of EMF 1 volt and internal resistance 1 ohm in bracket with their like poles are together. The combination is used to send current through an external resistance of 2 ohm. Calculate current through the external resistance for 3 marks. Now we have to solve this problem. See solution. First write down what is the given things here. That is the given data is there. Here 2 cells are given. That is E1 is equal to 4 volt. Then its internal resistance R1 is equal to 1 ohm and is connected in a parallel with another battery of EMF, that is E2 is equal to 1 volt and its resistance R2 is equal to 1 ohm. And then this is used to send current through external resistance of 2 volt. That value of external resistance R is equal to 2 ohm and we have to calculate current I through the external resistance. Now what is the circuit diagram for this problem? Now here consider the battery E1 and another battery E2. These are connected in parallel with their internal resistance. This is R1 and this is R2. This parallel combination is here connected to external resistance, which value R is equal to 2 ohm. And now what is the current flowing through this external resistance, that we have to calculate here. Now in previous year, what is the equivalent resistance is obtained, equivalent EMF obtained which are connected in parallel. Now first calculate the equivalent EMF, then R1 and R2, these resistors are connected in parallel combination. What is its equivalent resistance? Already we studied some formulas to obtain that equivalent EMF and equivalent resistance in a parallel combination. So E equivalent EMF equivalent, which is given by that E1 R1 plus E1 R2 plus E2 R1 divided by that R1 plus R2. Put these values. What is value of E1? Value of E1 is 4 into R2 1 plus that is a 1, E2 is 1 into R1 is 1 divided by that R1 plus R2, that is 1 plus 1. What is given? That is a 4 plus 1 divided by 2 is equal to 5 by 2 volt. This is the value of equivalent. Now R equivalent will be R1 R2 divided by R1 plus R2. Put the value of this R1 R2 is equals to that 1 into 1 divided by 1 plus 1 is equal to 1/2 ohm. This is the value of R equivalent. Now modify this combination like this one. This is the equivalent EMF, that is a E equivalent, which value is calculated 5 by 2 volt, and internal resistance, that is a R equivalent, which is equal to 1/2 ohm R, which value is 2 ohm. Then current will be I flowing through this one, that we have to calculate here. And now here these are internal resistance and this external resistance, both are in series. Therefore R equivalent is equal to, both are in series, that is a R equivalent internal resistance, this one plus this 2 is equal to 3 by 2. Sorry, 1/2 plus 2, that value comes to be 1 minute, 5 by 2 ohm. 4 plus 1, that is 5 divided by 2, get the 5 by 2 ohm. And now this circuit, final circuit will be, this is a positive terminal and this is the resistance R, and combination is like this one. This is the E equivalent and this is the external resistance. And what is the current flowing through this resistance I? We have to calculate applying Ohm's law. Phi is equal to IR, and therefore I is equal to Phi divided by R is equal to, what is V? Here Phi is the equivalent to that EMF equivalent divided by R, and that will be 5 by 2 divided by the value of this R equivalent, that is again a 5 by 2 is equal to 1 ohm. 1 ampere. Current can be measured in ampere, and therefore value of I is equal to 1 ampere. This is the answer. Current through the external resistance is 1 ampere. In this way, we can solve this problem number 1 here. Here given data is this one. From this numerical, we obtain this electrical circuit, then simplify it, and lastly find the current flowing through that external resistance R, which value comes to be I is equal to 1 ohm. It is very simple to calculate the current through this external resistance. Okay, now we can see again another problem number. These all problems are taking from exercise of your textbook of physics. According to your textbooks, this problem number is 10, and take the number of that problem is 11. According to this lecture, this is a problem number 2. What is this problem? Is the cells of EMF, the cells of EMF 1.5 volt and 2 volts having respective internal resistances, having respective internal resistances of 1 ohm and 2 ohm are connected in parallel, so as to send current in the same direction. Current in the same direction through an external resistance of of 5 ohm. Find the current through external resistance. Find current through external resistance. This is for 3 marks. First, write down what are given things here. Now, the cells of EMF, that is the value of E1 is 1.5 volt. Another cell E2, which value is 2 volt. Their internal resistance are, that is a small R1 is 1 ohm and R2 is equal to 2 ohm. Are connected in parallel so as to send currents in the same direction through an external resistance of 5 ohm. external resistance is 5 ohm. Find current through this external resistance, means we have to calculate this I. Same case is there. Now here consider two cells of EMF E1 and E2 and their internal resistance R1 and R2. Now here given that send current in the same direction, the current like this one. Now here make connection, here is the negative and then positive, then direction of current is like this one, direction of current is here again like this one. Now both currents are in same direction, therefore battery connections are here in a reverse way. And now this parallel combination is connected to external resistance, this R, and we have to calculate what is the current flowing through this resistance R. Okay. Now this is a E1, this is a E2, this is R1 and R2. Now this sources of EMF E1 and E2 are in parallel combination. We have to find a E equivalent, that is a E equivalent. What is formula for E equivalent? That E1 R2 plus E2 R1 divided by R1 plus R2. Put the value here. E1 is 1.5 into R2 is 2 plus E2 is 2 into R1 is 1 divided by R1 plus R2, that is 1 plus 2. Now make calculation, will be that 3 plus 2 divided by 3 is equal to 5 by 2. This is a E equivalent in volts. E equivalent is equal to 5 by 2 volt here. Now here we again calculate the value of internal resistance, that is a R equivalent. R equivalent is that R1 R2 divided by R1 plus R2. R1 is here 1, R2 is 2, that is a 1 into 2 divided by 1 plus 2 is equal to, that is 2 divided by 3 ohm. This is the value of R equivalent. Now this combination passes the current through that external resistance, and now after simplification, that circuit becomes, this is a source of EMF E, then this internal resistance, and this combination is connected to this external resistance R external here. This is a R equivalent and this is a E equivalent here. Already we calculated. We have to calculate what is the current I flowing through that resistance, and therefore that now here we are applying that Ohm's law to complete circuit. Then value of current I through this circuit, I is equal to that E divided by R1 plus R2 here. Here is the E equivalent, that these two resistance, that is R plus this internal resistance small r equivalent. Substituting the values of these two, what is the value of E equivalent? Here E equivalent we calculated there, that is the 5/2 divided by value of R is 5 plus this small r equivalent, that will be 2/3, and that values comes to be I is equal to this 5 divided by that 17 in ampere. This is the value of current. This current flowing through this external resistance I, which is equal to 5/17 ampere. Okay. See the problem number 3 here. A potentiometer wire has a length of 1.5 meter and resistance of 10 ohm. It is connected in series. With the cell of EMF, (4 volt) and internal resistance resistance 5 ohm. Calculate the potential drop per centimeter of the wire. Potential drop per centimeter of wire. This is again asked for 3 marks. See this problem here. Now, what is given? A potentiometer wire has a length of, here write a given data, for a solution of this problem, that length is given by 1.5 meter and resistance of that wire R is given here. R is equal to 10 ohm and EMF of source E is equal to 4 volt and their internal resistance is given 5 ohm, and we have to calculate potential drop per centimeter, that is the value of K, that is potential gradient. Here we have to calculate. Now, from potentiometer experiment. Here a wire AB, which length is given that L is equal to 1.5 centimeter, and their resistance of this wire R is equal to 10 ohm. And now this is connected to source of EMF E with internal resistance R, like this one. And here value of E is 5 volt and R is equal to that 5 ohm is given here. Now we have to calculate potential drop per centimeter of this wire. Now first calculate the current I is equal to, from Ohm's law applying to complete circuit, I is equal to R plus R here. I is equal to, that is a 4 divided by R is 10 plus 5, that is 4 divided by 15 ampere is the current here. Current flowing through this circuit. Now potential drop in wire. What is the potential? Potential drop in wire, that is phi is equal to IR. Okay. Current is 4 by 15 into value of resistance is 5. Then after calculation, that value comes to be that 8 divided by 3. Now here that will be 5, here 3, then get 4 into 2 divided by 3 here, then get 8 divided by 3 volt. This is the potential drop in wire. Now potential drop per meter, that will be this phi divided by L. Phi means your this potential drop in wire, that is the value of this one, this value. This is the value of phi here. Then 8 by 3 divided by length will be 1.5. That answer comes to be, that is 8 by 2, here 3 by 2, and that is comes to be 16 by 9 per meter here. We have to calculate potential drop per centimeter. Now potential drop per centimeter, potential drop per centimeter, then 16.9 multiply by 10 raised to minus 2 here, that get per centimeter potential, and that answer will be, after calculation, 0.0178 that is a potential, this volt per centimeter. This is a potential gradient. Last answer will be 0.0178 volt per centimeter. Understand this problem here? Here length and resistance of wire is given. This is the potentiometer AB wire, primary circuit here. Now applying the Ohm's law to this complete circuit, what is the current flowing? Already this formula is obtained in 11th standard, that is I is equal to E divided by R plus R. External resistance, internal resistance. Put this value, we get the what is the current flowing through this wire. Obtaining current, we have to obtain here potential drop in wire, that is a V. From Ohm's law, V is equal to IR. Put the value of I and R, get the answer 8/3 volt. That is the potential in wire. Now potential drop per meter, total length is 1.5 divided by this length, we get the potential drop per meter, that is 8/3 divided by 1/1.5. Make conversion and get the last answer 16/9 per meter, that is potential drop per meter. We have to convert that one in potential drop per centimeter. Now multiplying by this 10⁻⁻² and get the answer 0.0178 potential drop per centimeter. Okay, in this way we can solve the number of problems concerned with this current electricity. Now we can stop here. Okay.